Picture this. You're standing at the edge of what used to be a busy coastal area, watching as huge walls of water rush onto land faster than anyone could run. The year is 12,800 years ago, and the world is about to change forever. Above you, the sky glows with lines of fire as pieces rain down from space. Behind you, huge sheets of ice that have been there for thousands of years begin to break apart violently, letting loose floods that will change entire continents. This isn't a made-up story. This is the Younger Dryas, and it might just be the most important event in human history that you've never heard of. Welcome to another journey through the mysteries of our past, where we explore the shadows between what we think we know and what might actually be true. I'm your guide through these twilight hours, and tonight, we're diving deep into a question that could rewrite everything we believe about civilization itself. What if 12,800 years ago, an advanced human society was wiped from existence in just a few terrible decades? What if the stone circles, the giant stone monuments, the flood stories found in every corner of the globe aren't just coincidences, but pieces of memory from a world that was reset to zero? For the next hour, we'll follow the trail of evidence that suggests our ancestors might have been far smarter than we've been taught. We'll explore the scars in the ground left by space impacts, the mysterious timing of humanity's first giant buildings, and the possibility that beneath our oceans lie the ruins of cities that are older than everything we call civilization. This is a story about survival, about memory written in stone and myth, and about the strength of knowledge even in the face of worldwide disaster. So settle in. Let the familiar weight of sleep begin to pull at your mind, and join me as we uncover what might be the greatest reset in human history. The story begins not with a whisper, but with fire falling from the sky. Imagine the moment when early humans first noticed something wrong with the sky above. For weeks, perhaps months, strange lights had been dancing across the night sky. Shooting stars had become more common, brighter, more numerous. Then came the night when the sky itself seemed to crack open. What crashed into our planet 12,800 years ago wasn't just a single object. It was likely a huge comet, perhaps 60 miles wide, that had broken into countless pieces as it got close to Earth. These pieces, ranging from mountain-sized chunks to smaller but still deadly rocks, created a space shotgun blast that hit multiple continents at the same time. The evidence for this disaster lies written in the very dirt beneath our feet, in layers of dirt that contain materials that simply shouldn't exist naturally on Earth's surface. Across North America, Europe, the Middle East, and even South Africa, scientists have discovered what they call the black mat, a thin layer of darkened earth that appears like a scar in the rock record. Within these layers lie nanodiamonds, tiny crystals that can only form under the extreme pressure of space impact. There are metal spheres, tiny droplets of rock that were melted and thrown through the air before cooling and falling back to Earth. Higher levels of iridium and platinum, elements rare in Earth's surface, but common in asteroids and comets, jump dramatically in dirt from this exact time period. But perhaps most telling of all is what happens right after these black mat layers appear in the rock record. Above them, the bones of huge creatures that had walked the earth for millions of years simply vanish. Mammoths, mastodons, saber-toothed cats, dire wolves, giant ground sloths, and dozens of other species that had survived previous ice ages suddenly disappear from the fossil record. In North America alone, 35 groups of large mammals went extinct, representing the loss of roughly 70% of all large animal species on the continent. The human cost was likely just as terrible. The advanced Clovis culture, known for their beautifully made stone tools and successful big game hunting techniques, suddenly disappears from the archaeological record at exactly this same moment. Their distinctive spear points, which had been found across much of North America, are never seen again after the black mat layer. It's as if an entire way of life was erased in a geological instant. Now imagine you're one of the survivors of this space disaster. You've witnessed the sky burn with falling fire, felt the ground shake as huge impacts crater the landscape around you. and watched as the great herds that your people have followed for generations flee into smoke and chaos, never to return. But the immediate destruction is only the beginning of your ordeal. The debris thrown into the air by these impacts would have blocked out sunlight for months, perhaps years. Temperatures dropped as this space winter took hold, with some regions experiencing drops of up to 18 degrees Fahrenheit. But this wasn't just a temporary cooling. The impacts had triggered something far more dangerous, a complete shutdown of the ocean currents that control Earth's climate. The huge Laurentide ice sheet, which had covered much of northern North America, began to collapse as the impacts and resulting fires weakened its structure. Glacial Lake Agassiz, a body of fresh water larger than all the modern Great Lakes combined, burst through its ice walls and poured into the North Atlantic. This huge pulse of fresh water stopped the Atlantic meridional overturning circulation, the great ocean conveyor belt that carries warm water north and cold water south. Without this circulation system, the fairly mild conditions that had been emerging as the last ice age ended were suddenly reversed. The planet was thrown back into full ice age conditions in what scientists now call the Younger Dryas period. For 200 years, ice moved forward again across northern Europe and North America. Sea levels dropped as water was locked up in growing glaciers. Forests died and were replaced by frozen grassland. The brief warming trend that had promised a gentler world was brutally cut short. But here's where our story takes a fascinating turn. What if the world that was destroyed wasn't filled only by small groups of hunter-gatherers, living in simple shelters and following moving herds? What if there were already complex societies, early cities, advanced knowledge systems that were wiped away by this space reset? Consider the timing. The Younger Dryas impact happens 12,800 years ago. The world remains locked in this artificial ice age for over 1,000 years. Then almost immediately after the climate begins to get better again around 11,600 years ago, something remarkable happens. Göbekli Tepe, a huge stone temple complex in modern-day Turkey, begins construction. This isn't a simple arrangement of standing stones. It's an advanced building achievement, featuring carefully carved limestone pillars, weighing up to 20 tons each, arranged in perfect circles and decorated with detailed carvings of animals and strange symbols. The normal archaeological story tells us that Göbekli Tepe was built by hunter-gatherers who had somehow organized themselves into a workforce capable of digging up, moving and raising these huge stones without the benefit of tame animals, metal tools, or even pottery. They supposedly did this amazing feat before they had learned to farm, before they had permanent villages, before they had developed writing or any of the other things we connect with complex civilization. But what if Göbekli Tepe wasn't the beginning of giant building, but rather its rebirth? What if the knowledge and organization needed to create such structures had survived the Younger Dryas disaster, preserved by small groups of survivors who waited over 1,000 years for conditions to get better enough to begin building again? This possibility becomes even more interesting when we look at some of the carvings at Göbekli Tepe itself. The famous vulture stone, one of the most detailed carvings at the site, shows what some researchers believe to be a record of the space disaster that started the Younger Dryas. The stone shows various animals that may represent constellations, along with what appears to be a comet or meteor. Using computer software to match these carvings to actual star positions, researchers have calculated that the scene shown matches the night sky around 10 to 950 BCE, very close to the proposed date of the Younger Dryas impact. Could this stone be an ancient record, a deliberate attempt by survivors to preserve the memory of the disaster that had destroyed their world? If so, it would suggest that the builders of Göbekli Tepe had not only the technical skills to create giant buildings, but also advanced star knowledge and a complex system for recording and passing on information across generations. The mystery gets deeper when we consider that Göbekli Tepe was deliberately buried around 8,000 years ago. The site wasn't abandoned, and left to fall apart naturally. Instead, it was carefully covered with tons of earth and rubble, as if its creators wanted to preserve it for future discovery. Why would a society put in huge effort in creating such a wonderful complex, only to bury it on purpose? Perhaps because they knew their knowledge was fragile, that disasters could strike again, and that stone buried deep in the earth was the only way to make sure their message would survive. Göbekli Tepe isn't alone in this pattern. Across the globe, we find other examples of advanced giant stone construction that begins almost immediately after the end of the Younger Dryas. In Peru, the huge stone blocks of Sacsayhuaman fit together with such precision that a knife blade cannot slip between them. On Easter Island, nearly 900 huge statues stare inland from their coastal positions, their construction requiring advanced knowledge of engineering and planning. In Lebanon, the Baalbek complex features foundation stones weighing over 800 tons each, moved and positioned with a precision that challenges our understanding of ancient abilities. Each of these sites presents the same puzzle. How did societies that we're told were just coming out of primitive conditions suddenly show such advanced building and engineering knowledge? The normal explanation requires us to believe in multiple separate inventions of advanced construction techniques, each happening on its own in different parts of the world, within a few thousand years of the Younger Dryas ending. But there's another explanation, one that the growing body of evidence seems to support. What if these weren't separate inventions at all, but rather the reappearance of knowledge that had existed before the space reset? What if scattered survivors of a more advanced pre-Younger Dryas civilization had preserved pieces of their building, star and engineering knowledge through the dark centuries of the artificial ice age, waiting for conditions to improve enough to begin building again? This possibility is supported by more than just the mysterious timing of giant stone construction. In recent years, improvements in underwater archaeology and satellite imaging have shown structures on continental shelves around the world that appear to be artificial but are underwater under hundreds of feet of water. Off the coast of India in the Gulf of Khambat, sonar has detected what appear to be geometric patterns and structures buried under ocean dirt. Near the Bahamas, underwater formations known as the Bimini Road show straight arrangements of stone blocks that some researchers argue are too regular to be natural. These underwater oddities become especially important when we remember that sea levels at the end of the last ice age were nearly 400 feet lower than they are today. Huge areas of what is now ocean floor were dry land during the period leading up to the Younger Dryas impact. The Doggerland Plain connected Britain to continental Europe. The Sunda Shelf linked Southeast Asia into a single landmass. Coastal plains stretched far beyond their current boundaries on every continent. If advanced civilizations had developed during the thousands of years before the Younger Dryas, they would most likely have been located in these fertile coastal areas with access to ocean resources and river deltas. When the impact triggered climate changes that caused huge ice sheets to collapse and sea levels to rise quickly, these coastal civilizations would have been the first victims. Their cities, their ports, their farming areas, and their populations would have been covered beneath hundreds of feet of rising ocean. This scenario would explain one of the most persistent mysteries in human cultural development. Why do flood myths appear in virtually every human society on Earth? From the biblical story of Noah to the Mesopotamian epic of Gilgamesh, from Hindu traditions of Manu to Native American stories of world-cleansing floods, cultures that had no contact with each other all preserved stories of a great flood that destroyed an earlier world. Anthropologists have traditionally explained these similarities as symbolic myths that arise naturally from human psychology, metaphors for spiritual rebirth and renewal. But what if there's something else entirely? What if they're cultural memories of actual events passed down through thousands of generations by the descendants of survivors who watched their coastal homelands disappear beneath rising seas? The power of oral tradition to preserve historical information across huge time periods has been greatly underestimated by modern scholars. Aboriginal Australians have kept accurate oral histories of geological events that happened more than 30,000 years ago. These stories describe specific landscapes, volcanic eruptions, and sea level changes that have been confirmed by modern scientific research. If oral tradition can preserve accurate information about events from 30,000 years ago, it can certainly preserve memories from 12,800 years ago. But the survivors of the Younger Dryas disaster didn't rely only on oral tradition to preserve their knowledge. They wrote it in stone in mathematical relationships, in star alignments that would outlast any spoken word. The great stone circles, the giant stone temples, the precisely aimed pyramids and monuments that appear around the world in the thousands of years following the Younger Dryas are fragments of a huge knowledge preservation system, an ancient library written in stone and geometry. Consider what this stone library means. When we look at sites like Stonehenge, Newgrange, or the stone circles scattered across Britain and Ireland, we find structures aligned with extraordinary precision to space events. The huge stone arches at Stonehenge frame the sunrise on the summer solstice with mathematical accuracy. The passage tomb at Newgrange in Ireland channels the light of the winter solstice dawn into its inner chamber, lighting up ancient spiral carvings that seem to dance in the brief golden light. These aren't random directions. They represent advanced understanding of astronomy, geometry, and engineering that require generations of careful observation and mathematical calculation. But here's what makes this even more remarkable. The knowledge built into these structures often goes beyond what would have been necessary for the simple farming societies we believe built them. Why would Stone Age farmers need to track the precession of the equinoxes, a cycle that takes 26,000 years to complete? Why would they write complex mathematical constants like pi and phi into their stone monuments? Why would they align their structures not just with obvious sky events like solstices, but with subtle space things that require advanced understanding of how celestial bodies move? The answer might be that they weren't creating this knowledge from scratch. They were rebuilding it, restoring star and mathematical systems that had been developed long before the space disaster reset their world. This preservation of advanced knowledge becomes even more interesting when we look at the mysterious appearance of farming itself. The normal story tells us that humans discovered farming independently in multiple locations around the world within a few thousand years of each other shortly after the end of the Younger Dryas. In the Fertile Crescent, people suddenly began growing wheat and barley. In China, they started growing rice. In Mesoamerica, they developed corn. In the Andes, they tamed potatoes and quinoa. This simultaneous farming revolution across disconnected continents has always puzzled researchers. How did hunter-gatherer societies around the world all come up with the same revolutionary idea within such a narrow time window? The standard explanation involves climate change creating conditions that helped plant growing. But this doesn't fully explain the advanced understanding of selective breeding, crop rotation, and farming planning that early farming required. What if farming wasn't invented after the Younger Dryas, but reinvented? What if survivors of the disaster had knowledge of plant growing that had been developed over thousands of years before the space impact? During the long centuries of the artificial ice age, this knowledge would have been mostly unusable. But as soon as climate conditions got better, survivors could have begun teaching farming techniques to the hunter-gatherer populations they met, starting the rapid farming revolution that followed. This scenario gains support when we look at the genetic history of our most important crop plants. Many of them show signs of having been carefully bred from wild ancestors, in ways that would have required advanced understanding of plant genetics and breeding techniques. The change of wild teosinte into modern corn, for example, involved genetic changes so complex that some researchers have argued they couldn't have happened through simple trial and error by primitive farmers. But the evidence for pre-Younger Dryas civilization isn't limited to farming and giant stone construction. In recent decades, Underwater archaeologists have begun exploring underwater continental shelves with increasingly advanced technology, and what they're finding challenges our understanding of early human development. Off the coast of Gujarat in western India, marine archaeologists have discovered what appear to be the remains of a large city settlement underwater in 120 feet of water. The structures shown through sonar and underwater scanning show regular geometric patterns consistent with planned city development. Pottery pieces and other artifacts recovered from the site have been carbon dated to over 9,000 years old, making this potentially one of the oldest city settlements ever discovered. Similar underwater oddities have been found off the coasts of Japan, Cuba, and the eastern Mediterranean. Near Yonaguni Island in Japan, divers have explored what appears to be a huge stepped pyramid complex carved from solid rock and underwater beneath 75 feet of water. The structure features right-angle cuts, geometric shapes, and what appear to be stairs and terraces that are difficult to explain as natural formations. In the waters off Cuba, sonar mapping has shown geometric stone structures at depths of 2,100 feet, far deeper than any known ancient human settlement. The structures appear to include pyramids, circular buildings, and what looks like a large city complex covering several square miles of ocean floor. The depth at which these structures lie suggests they would have been underwater for at least 12,000 years, placing them firmly in the pre-Younger Dryas time period. These underwater discoveries face intense doubt from mainstream archaeology, and for understandable reasons. Accepting their artificial origin would require a fundamental change of our timeline of human development. But as underwater exploration technology continues to improve, more of these strange structures are being discovered, and it becomes increasingly difficult to dismiss them all as natural formations or wrong interpretations. The resistance to these discoveries reveals something important about how scientific thinking changes. Thomas Kuhn, in his groundbreaking work on scientific revolutions, noted that new ways of thinking aren't accepted gradually. Instead, they face fierce resistance until the weight of contradicting evidence becomes so overwhelming that the old way of thinking suddenly collapses and is replaced by the new one. We may be approaching such a shift in thinking in our understanding of early human civilization. The evidence for advanced pre-Younger Dryas societies continues to build from multiple independent sources. Genetic analysis reveals ghost populations in human DNA, ancient family lines that contributed to modern populations but have no clear archaeological matches. These genetic ghosts suggest that complex population movements and mixtures happened in prehistory that aren't explained in our current models of human development. Advanced dating techniques applied to giant stone sites consistently push their origins back earlier than expected. Göbekli Tepe itself has been redated multiple times, with the oldest structures now believed to be over 12,000 years old. Similar changes have happened at sites around the world as new dating methods reveal greater age than previously thought. Perhaps most interestingly, computer modeling of ancient star alignments is showing that many giant stone sites contain advanced knowledge of space cycles that wouldn't have been directly observable by their supposed builders. The Nebra sky disk, discovered in Germany and dated to about 3,600 years ago, shows star knowledge that required centuries of careful observation to develop. Yet it appears in the archaeological record without any clear developmental sequence, showing how this knowledge was gained. This pattern repeats across cultures and continents. Advanced star, mathematical and engineering knowledge appears suddenly in the archaeological record, fully formed and without clear beginnings. It's as if someone had flipped a switch, turning on advanced knowledge systems that had been sleeping for over 1,000 years. The switch, of course, was the end of the Younger Dryas artificial ice age. As temperatures warmed and ice sheets pulled back, as sea levels got steady and ecosystems recovered, the conditions became right for civilization to come out of its long sleep. The survivors who had preserved pieces of pre-disaster knowledge could finally begin the work of rebuilding. But they weren't starting from a blank slate. They carried with them the memories, the techniques, and the wisdom of the world that had been lost. This explains why the earliest post-Younger Dryas civilizations show such remarkable skill. They weren't primitive societies slowly developing new technologies. They were inheritors of a broken tradition, working to rebuild what had been destroyed. This inheritance wasn't limited to practical knowledge. It included spiritual and philosophical systems that had been developed over thousands of years before the space reset. The mystery schools of ancient Egypt, the shamanic traditions of the Americas, the philosophical insights of early Indian civilization all may trace their roots back to pre-disaster, wisdom traditions that were preserved through the dark centuries, and finally, able to grow again as the world healed. The great temples and monuments that arose in the thousands of years following the Younger Dryas weren't just impressive building achievements. They were statements of defiance against the forces that had nearly erased human civilization. They declared that knowledge could survive disaster, that human wisdom could outlast space destruction, and that the achievements of the past would not be forgotten. In the precision of their construction, the advancement of their star alignments, and the mathematical constants written into their proportions, these monuments carried forward the intellectual achievements of the lost world. They served as both libraries and schools, preserving ancient knowledge while teaching it to new generations who had grown up in the post-disaster world. As we drift deeper into this ancient mystery, consider what we've explored. If human civilization is indeed far older and more advanced than we've been taught, then our species has faced and survived a space disaster of unimaginable size. We are the descendants not just of hunter-gatherers who discovered farming, but of survivors who rebuilt their world from pieces and memories after watching everything they knew disappear beneath fire, ice, and rising seas. This story of survival and rebuilding continues to unfold as new evidence comes out from beneath the waves, within genetic codes, and in the star alignments of ancient monuments. The next chapter of our journey will take us deeper into the specific ways of destruction and preservation, exploring how knowledge can survive when civilizations cannot, and how the careful study of myth and monument continues to reveal the hidden history of our species. This story of strength becomes even more compelling when we look at the curious spread of certain technologies and symbols across the ancient world. In the thousands of years following the Younger Dryas, we find remarkably similar construction techniques appearing at the same time in locations separated by huge oceans and continents. The precision-cut stone blocks of Pumapunku in Bolivia mirror those found at Sacsayhuaman in Peru, yet both echo the giant stone construction methods seen at sites like Baalbek in Lebanon and the Cyclopean walls of ancient Greece. These aren't simple similarities that might come from parallel development. They represent specific technical solutions to complex engineering problems. The H-shaped clamps used to join huge stone blocks in ancient Peru appear in identical form at sites in Egypt and Easter Island. The technique of cutting and fitting enormous stones with such precision that no cement is needed shows up independently across multiple continents within centuries of each other. How do we explain this? The normal archaeological model requires us to believe that dozens of separate cultures independently developed identical solutions to problems they shouldn't have even faced in their supposed developmental stages. It's like finding the same complex math equation solved identically by students who never went to the same school, never shared textbooks, and lived in completely different centuries. But if these techniques were part of a knowledge system that came before the Younger Dryas disaster, then their appearance at the same time makes perfect sense. Survivors carrying pieces of ancient engineering knowledge would have eventually found suitable stone deposits and stable enough social conditions to begin construction projects. The techniques would have come out not as inventions, but as recovered memories being applied to new situations. This pattern extends beyond construction methods to include symbolic systems that appear across ancient cultures with startling consistency. The spiral, perhaps the most common symbol in prehistoric art, appears carved in stone from Ireland to New Mexico, from Australia to Siberia. These aren't simple decorative patterns. Complex spiral patterns contain mathematical relationships, star cycles, and what appear to be advanced mapping systems. At Newgrange in Ireland, the famous triple spiral carved at the entrance to the passage tomb uses precise mathematical ratios that relate to the monument's star alignments. Similar mathematical spirals appear in the rock art of the American Southwest, where they seem to track sun and moon cycles with remarkable accuracy. In Australia, Aboriginal Dreamtime symbols include spiral patterns that contain complex navigation information, allowing travelers to find water sources and safe passage across huge distances. These symbolic systems suggest something far more important than decorative art created by primitive societies. They point to a shared mathematical and star language that went beyond cultural boundaries. This language appears suddenly in the archaeological record, fully formed and advanced, without clear developmental beginnings in any of the cultures that used it. Consider what this means. If scattered survivors of a pre-Younger Dryas civilization carried with them not just practical knowledge, but also symbolic and mathematical systems, then the reappearance of similar symbols across disconnected cultures represents the rebuilding of a lost universal language. The monuments themselves become libraries, their carved symbols preserving information that could survive even if the people who created them did not. This possibility gains support from recent advances in archaeoastronomy, the study of how ancient monuments relate to space things. Researchers have discovered that many giant stone sites contain information about star cycles that go far beyond what would have been needed for simple farming calendars. Some monuments track the precession of the equinoxes, a 26,000-year cycle that was supposedly unknown to ancient peoples. Others align with star positions that would have been accurate, not for the time of their construction, but for periods thousands of years earlier. The Great Sphinx of Giza provides a fascinating example of this time displacement. While mainstream archaeology dates the monument to around 2500 BCE, its precise star alignment matches a much earlier period. The Sphinx looks directly east, and computer models of ancient star positions reveal that it would have looked straight at the constellation Leo during the spring equinox around 10,500 BCE. This date falls exactly within the period immediately following the end of the Younger Dryas. Similar time displacements appear at giant stone sites around the world. The alignment of the Giza pyramid complex with the constellation Orion matches most precisely to star positions from around 10,500 BCE, not to the supposed construction date thousands of years later. The stone circles of Nabta Playa in the Egyptian desert align with star configurations from approximately 11,000 years ago, yet the normal dating of the site places its construction much later. These star alignments suggest that the builders of these monuments had detailed knowledge of star positions from a much earlier time. How could Bronze Age or Stone Age societies have known the precise positions of stars from thousands of years before their time? The most logical explanation is that they inherited this knowledge from earlier observations, preserved through the dark centuries of the Younger Dryas, and finally written in stone when conditions allowed for monument construction to start again. The preservation of such precise star knowledge points to advanced methods of information storage and passing on that we're only beginning to understand. Recent research into the information content of giant stone monuments reveals that they work as complex data storage systems, containing multiple layers of information in their proportions, alignments, and geometric relationships. The Great Pyramid of Giza, for example, uses the mathematical constant pi in its proportions, writes the precise dimensions of the Earth in its measurements, and aligns with magnetic north to within 1/60th of a degree. These aren't coincidences or approximations. They represent intentional writing of advanced mathematical and geographical knowledge into a structure designed to survive for thousands of years. Similar information writing appears in giant stone sites around the world. Stonehenge uses complex geometric relationships that contain star cycles, mathematical constants, and what appear to be units of measurement based on precise knowledge of Earth's dimensions. The stone circles of the British Isles together form geometric patterns that some researchers argue represent a huge land survey system containing geographical information across hundreds of miles of landscape. This suggests that the post-Younger Dryas monument builders weren't just creating impressive structures. They were rebuilding a global information network, a stone internet, that could preserve and pass on complex knowledge across huge distances and time periods. Each monument served as both a point in this network and a storage device, holding specific pieces of a much larger knowledge system. The network idea becomes even more interesting when we look at the positioning of giant stone sites relative to each other. Many appear to be connected by geometric relationships that span continents. The Great Circle distance between Giza and Stonehenge, for example, equals exactly 1/16 of the Earth's circumference. The distance from Stonehenge to the stone circles of the Orkney Islands uses precise geometric ratios that appear to be intentional rather than coincidental. These geometric relationships suggest that the builders of giant stone monuments had accurate knowledge of Earth's dimensions and used this knowledge to position their structures according to a global plan. This level of geographical knowledge shouldn't have existed in Stone Age or Bronze Age societies, yet the evidence of its use appears carved in stone across multiple continents. The effects extend beyond individual monuments to include entire landscapes. In Britain, researchers have identified what they call an ancient survey system, a network of geometric relationships connecting stone circles, standing stones and other giant stone sites across hundreds of miles. The system appears to be based on precise units of measurement and advanced understanding of geometry and surveying techniques. Similar landscape-scale geometric relationships have been identified in other parts of the world. The positioning of ancient sites in Egypt follows geometric patterns that extend from the Mediterranean coast to the southern borders of the ancient kingdom. In Peru, the Nazca lines create geometric patterns visible only from the air, suggesting that their creators had either flight abilities or extremely advanced surveying techniques. The appearance of such complex landscape geometry in multiple locations around the world points to the existence of a shared system of geographical knowledge that went beyond individual cultures. This system appears suddenly in the archaeological record, fully developed and advanced without clear beginnings. If this geographical knowledge system came before the Younger Dryas disaster, then its reappearance in the post-disaster world represents one of the most remarkable achievements in human history. Survivors carrying pieces of ancient surveying and star knowledge would have needed to rebuild not just individual monuments, but an entire global network of precisely positioned reference points. The scale of such a project suggests levels of coordination and communication between distant cultures that challenge our understanding of ancient societies. How did builders in Britain coordinate with those in Egypt to make sure their monuments kept precise geometric relationships across thousands of miles? How did cultures that supposedly had no contact with each other use identical measurement systems and construction techniques? The answer may lie in the nature of the knowledge preservation system itself. If the pre-Younger Dryas civilization had developed advanced methods for writing and passing on information, then survivors scattered across the globe could have kept contact through shared symbolic and mathematical languages. The monuments themselves could have served as communication devices, their precise alignments and proportions sending complex information to those who knew how to read them. This communication network might explain one of the most persistent mysteries in ancient studies, the sudden appearance of similar religious and mythological ideas in cultures that had no apparent contact with each other. The flood myths we discussed earlier are just one example of shared stories that appear across disconnected civilizations. Creation stories, hero myths, and spiritual concepts show remarkable similarities, even between cultures separated by oceans and thousands of years. These shared mythological patterns have traditionally been explained as symbolic stories that come naturally from human psychology. But what if they represent something more concrete? What if they're pieces of actual historical stories preserved through oral tradition and eventually built into the religious and cultural systems of post-Younger Dryas civilizations? The possibility that myths contain hidden historical information gains support from recent studies of oral tradition among indigenous cultures. Aboriginal Australians have kept accurate historical accounts of geological events, sea level changes, and landscape changes across tens of thousands of years. Their Dreamtime stories, long dismissed by Western scholars as primitive creation myths, have been shown to contain precise information about ancient geographical features, extinct animals, and environmental changes that happened during the last ice age. If Aboriginal oral tradition can preserve accurate information across 30,000 or more years, then similar traditions in other cultures could easily preserve memories from the much more recent Younger Dryas period. The flood myths, creation stories, and tales of lost golden ages that appear in cultures around the world might represent pieces of actual historical memory passed down through generations of survivors and their descendants. This interpretation changes our understanding of ancient mythology from primitive superstition to advanced information preservation system. The stories weren't just entertainment or spiritual guidance, they were libraries containing crucial historical and geographical information in story forms that could survive even when written records could not. The dual function of myth as both story and information storage device appears in the structure of many ancient stories. They often include specific geographical details, star references, and technical information built into the plot. The Epic of Gilgamesh, for example, contains precise descriptions of ancient Mesopotamian geography, detailed accounts of construction techniques, and what appear to be hidden star observations. Similar technical information appears built into mythologies around the world. Hindu texts contain detailed descriptions of mathematical concepts, star cycles, and what some researchers argue are accounts of advanced technologies. Norse sagas include geographical information about Atlantic navigation routes and descriptions of lands that wouldn't be officially discovered by Europeans for centuries. Native American traditions preserve accurate information about ancient geological events, extinct species, and environmental changes that happened thousands of years before European contact. The writing of technical and historical information in mythological stories represents one of humanity's most advanced survival strategies. Unlike written records, which can be destroyed by fire, flood, or war, oral traditions can survive as long as there are people to remember and retell them. By building crucial information in memorable stories, ancient cultures made sure that essential knowledge would continue even through periods of social collapse and environmental disaster. This preservation system becomes even more remarkable when we consider the precision with which information was kept across generations. Studies of traditional storytelling cultures reveal that oral stories can remain virtually unchanged for thousands of years when they're considered sacred or historically important. The ways of social reinforcement, ritual repetition, and cultural authority that keep oral tradition accuracy are far more strong than most modern scholars had assumed. The effect is that the mythologies of ancient cultures may preserve accurate historical information from periods far earlier than previously thought possible. If survivors of pre-Younger Dryas civilizations wrote their experiences and knowledge in oral stories, then these stories could have preserved detailed accounts of the space disaster and its aftermath for over 12,000 years. This possibility reframes our entire approach to studying ancient cultures. Instead of dismissing myths as primitive fiction, we should be analyzing them as potential historical documents, looking for hidden information about past events, lost technologies, and forgotten knowledge systems. The stories our ancestors told around fires might contain more truth than the textbooks we study in schools. The coming together of evidence from multiple sources, star alignments, genetic analysis, underwater archaeology, and mythological studies creates a strong case for completely changing our timeline of human civilization. The picture that comes out suggests that our species achieved far greater advancement far earlier than we've been taught, only to have that achievement nearly erased by space disaster. The survivors of this erasure faced a challenge that tests the very limits of human strength. They had to preserve pieces of advanced knowledge through over 1,000 years of harsh climate conditions, social disruption, and cultural collapse. They had to keep hope that conditions would eventually improve enough to allow rebuilding. And they had to develop systems for passing their knowledge to future generations who would have grown up in a world very different from the one that had been lost. That they succeeded in this huge task is shown by the sudden flowering of advanced civilizations in the thousands of years following the end of the Younger Dryas. The appearance of complex societies in Mesopotamia, Egypt, the Indus Valley, and Peru wasn't the beginning of civilization. It was its rebirth, the return of human achievement after the longest dark age in recorded history. As we continue our journey through this hidden history, we'll explore how these rebirth civilizations wrote their recovered knowledge, how they built upon the pieces preserved by survivors, and how traces of the lost world continue to surface in archaeological discoveries around the globe. The story of the Younger Dryas reset is far from over. In fact, as new evidence comes out and new technologies allow us to look deeper into the past, we're only beginning to understand the true size of what was lost and what was miraculously preserved. The story becomes even more extraordinary when we look at what happened right after the Great Warming. As the Younger Dryas Ice Age finally let go around 11,600 years ago, something never before seen happened in human development. Within just centuries of climate stabilization, we see the sudden appearance of advanced farming systems, giant building, and complex social organizations across multiple continents at the same time. This timing isn't a coincidence. It's as if humanity had been waiting, holding its breath through the long, cold centuries, ready to breathe out a rebirth of knowledge and achievement the moment conditions allowed. But the speed and advancement of this appearance challenges everything we think we know about how civilizations develop. Traditional archaeological models suggest that complex societies grow gradually over many thousands of years. Hunter-gatherers slowly develop farming, which leads to permanent settlements, which eventually grow into cities, which finally produce the extra resources and organization necessary for giant construction projects. This process should take thousands of years, not centuries. Yet what we observe in the archaeological record following the Younger Dryas is the opposite pattern. Complex achievements appear suddenly, fully formed as if someone had simply flipped a switch. The great temple complexes of Göbekli Tepe begin construction almost immediately after the ice pulls back. Advanced farming systems appear at the same time in the Fertile Crescent, China, Mesoamerica, and the Andes. Giant stone construction projects start across Europe, Africa, and the Americas within a remarkably narrow time window. This pattern suggests that the knowledge necessary for these achievements already existed, waiting for the right conditions to be used. The survivors who had preserved pieces of pre-disaster civilization weren't starting from zero. They were working from blueprints, both real and symbolic, that had been carefully kept through the dark centuries. Consider how complex what appeared so quickly actually was. The farming systems that appeared after the Younger Dryas weren't simple experiments in plant growing. They involved advanced understanding of selective breeding, crop rotation, water engineering, and food storage techniques. The change of wild grasses into productive cereals required genetic changes so complex that some modern plant scientists argue they couldn't have happened through random experimentation by primitive farmers. Take wheat, for example. The journey from wild einkorn grass to the bread wheat that fed early civilizations involved multiple genetic changes that had to happen in specific order. Wild wheat shatters when ripe, scattering its seeds naturally but making harvesting nearly impossible. Cultivated wheat keeps its seeds until harvested, but this trait would be deadly in wild conditions. The development of non-shattering wheat varieties required deliberate selection over many generations, along with knowledge to recognize and preserve helpful mutations. Similarly, the change of teosinte into modern corn involved genetic changes so dramatic that the two plants appear to be completely different species. The process required advanced understanding of plant genetics, selective breeding techniques, and long-term farming planning. Yet this change supposedly happened independently in Mesoamerica, within centuries of similar farming developments in other parts of the world. The appearance at the same time of complex farming across disconnected continents becomes even more mysterious when we look at the specific techniques involved. Terrace farming appears in the Andes, China, and the Mediterranean at roughly the same time. Advanced water systems appear in Mesopotamia, the Indus Valley, and Peru within centuries of each other. Advanced food storage and processing techniques develop independently across multiple cultures. These aren't simple innovations that might come naturally from trial and error. They represent complex technological systems that require deep understanding of water science, soil chemistry, plant biology, and engineering principles. The knowledge base necessary to develop such systems should have taken thousands of years to build up through gradual experimentation and improvement. But what if it hadn't been built up gradually? What if this farming knowledge represented the recovery of systems that had been developed over thousands of years before the Younger Dryas disaster? Survivors carrying this knowledge would have been unable to use it during the harsh conditions of the artificial ice age. But as soon as climate conditions got better, they could have begun teaching these techniques to hunter-gatherer populations, starting the rapid farming revolution that changed human society. This scenario explains not only the speed of farming development, but also its advancement. The early farmers weren't experimenting with primitive techniques. They were using advanced systems that had been improved over thousands of years of pre-disaster development. The farming revolution wasn't an invention, but a restoration, the recovery of knowledge that had been temporarily lost to terrible climate change. The same pattern appears in giant building. The advanced construction techniques that appear suddenly in the post-Younger Dryas world aren't the crude first attempts of societies learning to build with stone. They represent advanced engineering knowledge applied to new situations by people who understood principles of leverage, transportation, precision cutting, and structural stability. The giant stone sites that appeared during this period show consistent features that suggest a shared knowledge base. Huge stone blocks are cut and fitted with mathematical precision. Structures are aligned with star things, using advanced understanding of how celestial bodies move. Construction techniques appear that wouldn't be rediscovered by mainstream archaeology until the modern era. At Pumapunku in Bolivia, stone blocks weighing over 130 tons are cut with such precision that they fit together like pieces of a three-dimensional jigsaw puzzle. The cutting techniques involved required tools and methods that supposedly didn't exist in pre-Columbian America. The blocks contain complex interlocking shapes that would challenge modern stone cutters equipped with diamond-tipped tools and computer-controlled machinery. Similar precision appears at giant stone sites around the world. The trilithon stones at Baalbek in Lebanon are fitted together so precisely that their joints remain invisible after thousands of years of weathering and earthquake activity. The Cyclopean walls of ancient Peru use stones of such varied shapes and sizes that each block appears to have been custom cut to fit its specific position in the wall structure. This level of precision suggests that the builders had not only advanced tools, but also advanced planning and measurement systems. They needed to know exactly how each stone would fit before beginning the cutting process. They required accurate surveying techniques to make sure that huge blocks transported over long distances would align perfectly with structures already in place. The knowledge systems necessary for such achievements don't develop overnight. They require generations of built-up experience, improved techniques, and institutional memory. Yet they appear suddenly in the archaeological record, fully formed and advanced across multiple continents within centuries of the Younger Dryas ending. The mystery gets deeper when we look at the star alignments built into these giant stone structures. The builders didn't just have advanced construction techniques, they also showed advanced understanding of how celestial bodies move, mathematical relationships, and complex geometric principles. Many post-Younger Dryas monuments contain star information that goes far beyond simple seasonal calendars. They track complex space cycles, use mathematical constants, and align with star things that require centuries of careful observation to understand fully. The knowledge built into these structures suggests that their builders inherited star systems developed over thousands of years of pre-disaster observation and calculation. The Antikythera mechanism, discovered in an ancient Greek shipwreck, provides a fascinating example of the advancement that could come from recovered knowledge systems. This bronze device, dating to around 100 BCE, works as a complex analog computer capable of predicting eclipses, tracking planetary positions, and calculating the timing of Olympic Games decades in advance. The mechanism uses gear ratios of extraordinary precision, mathematical relationships that weren't supposedly rediscovered until the Renaissance, and star knowledge that required centuries of careful observation to develop. Yet it appears suddenly in the archaeological record without clear beginnings, as if someone had simply remembered how to build such devices after a long period of forgetting. Similar examples of advanced knowledge appearing without clear origins can be found across ancient civilizations. The mathematical and star texts of ancient India contain advanced calculations, geometric principles, and star observations that suggest access to knowledge systems far more advanced than traditional timelines would suggest possible. The Surya Siddhanta, an ancient Sanskrit text on astronomy, contains calculations of planetary orbits, star positions, and cosmic cycles that remain accurate by modern standards. The text includes mathematical concepts like trigonometry and calculus that weren't supposedly developed until much later periods. It describes the Earth as a sphere rotating on its axis, concepts that mainstream history claims weren't understood until relatively recent times. Egyptian mathematical papyri reveal similar advancement in geometric principles, algebraic calculations, and engineering applications. The builders of the pyramids clearly had advanced mathematical knowledge, using precise geometric relationships, mathematical constants, and complex proportional systems into their monuments. But where did this knowledge come from? The normal archaeological story requires us to believe that these advanced mathematical and star systems were developed independently by multiple cultures within relatively short time periods. It's as if several different groups of people had at the same time invented calculus, discovered the same geometric principles, and developed identical star models without any communication between them. The alternative explanation suggests that these knowledge systems weren't inventions but recoveries. Survivors of pre-Younger Dryas civilizations had preserved pieces of advanced mathematical, star, and engineering knowledge through the terrible period. As conditions got better, this knowledge began to resurface in the civilizations that came from the survivors' teachings and influence. This possibility gained support from the genetic evidence of human population movements during the post-Younger Dryas period. DNA analysis reveals complex patterns of migration and mixing that happened as climate conditions improved and sea levels got steady. These population movements weren't random wanderings of primitive hunter-gatherers. They represent organized moves of people carrying specific knowledge and skills to new territories. The genetic signatures of these migrations appear in modern populations as ghost lineages, traces of ancient groups that contributed to later civilizations but have no clear archaeological matches. These genetic ghosts suggest that big population movements happened during the immediate post-Younger Dryas period, movements that could have spread preserved knowledge across huge distances. One particularly interesting genetic signature appears in the DNA of early farming populations across Eurasia and Africa. These groups show evidence of mixing from unknown populations that don't match any surviving hunter-gatherer groups from the same time periods. The genetic contributions appear suddenly in the record, suggesting that organized groups with different backgrounds had mixed with local populations during the farming transition. These mysterious genetic contributors might represent the survivors we've been discussing, people who had kept different lifestyles and knowledge systems through the Younger Dryas period and came out to share their skills as conditions improved. Their genetic signatures would have been preserved in the populations they taught and influenced, creating the ghost lineages that puzzle modern researchers. The cultural effects of such genetic mixing go far beyond simple population movements. When groups with advanced knowledge mix with local populations, they don't just contribute genes. They contribute ideas, techniques, languages, and entire knowledge systems that can transform the receiving cultures. This cultural transfer might explain the sudden appearance of advanced technologies and concepts in archaeological sites around the world. Advanced metalworking, complex star knowledge, advanced building techniques, and detailed artistic traditions all appear suddenly in the post-Younger Dryas record, often without clear developmental sequences in the cultures that show them. The timing of these appearances matches closely with the genetic evidence of population mixing, suggesting that knowledge transfer went along with genetic mixing. The survivors weren't just preserving their own cultural traditions. They were actively teaching and sharing their knowledge with the hunter-gatherer populations they met as they came out of their shelters. This sharing process might have been formalized through institutional structures designed to preserve and pass on knowledge across generations. The mystery schools of ancient Egypt, the star colleges of Mesopotamia, and the craft guilds of giant stone Europe might all represent institutional continuations of knowledge preservation systems that had survived the Younger Dryas disaster. These institutions served dual functions as both storage places of ancient knowledge and training centers for new practitioners. They kept the advanced techniques necessary for giant construction, star observation, and complex social organization, while also adapting these techniques to new situations and local conditions. The institutional preservation of knowledge explains how complex techniques could be kept across generations and passed on across huge distances. Unlike individual skill, which dies with its owner, institutionalized knowledge can survive social disruptions, environmental disasters, and cultural changes. The institutions themselves become vehicles for carrying advanced knowledge through periods of instability and into new eras of development. This institutional model also explains the remarkable consistency of techniques and symbols across widely separated ancient cultures. If survivors had set up similar knowledge preservation institutions in different parts of the world, these institutions would have kept similar techniques, symbols, and practices even as they adapted to local conditions and mixed with local populations. The result would be the pattern we observe in the archaeological record: advanced techniques and symbols appearing at the same time across disconnected cultures, showing remarkable similarities, while also showing adaptations to local materials, climate conditions, and cultural preferences. As we go deeper into this hidden history, the evidence continues to build from multiple independent sources. Genetic analysis, star alignments, construction techniques, mythological parallels, and geological evidence all point toward the same conclusion. Human civilization is far older and more advanced than normal timelines suggest, and the Younger Dryas period represents not the beginning of complexity, but its recovery after a terrible interruption. The effects of this hidden history go far beyond academic debates about ancient cultures. They suggest that human knowledge and achievement are far more strong than we might expect. capable of surviving even space disasters that reset entire civilizations. They point toward advanced systems for preserving and passing on crucial information across generations and through periods of extreme social and environmental stress. Most importantly, they remind us that our current civilization stands on foundations laid by ancestors who had knowledge and abilities that we're only beginning to understand. The monuments they left behind aren't just impressive ancient buildings. They're libraries written in stone, storage places of knowledge that continue to reveal their secrets as our own understanding grows. The story of the Younger Dryas reset isn't just ancient history. It's a testament to human strength, cleverness, and the power of knowledge to survive even when civilizations cannot. As we face our own challenges and uncertainties, the example of those ancient survivors offers both inspiration and practical lessons about the importance of preserving knowledge, keeping institutional memory, and building systems that can last through periods of change and disruption. Their success in rebuilding from pieces and memories, after watching their world disappear beneath fire, ice, and rising seas, stands as one of the greatest achievements in human history. The civilization we live in today exists because they refused to let knowledge die, because they found ways to preserve what mattered most, and because they never stopped believing that what was lost could be recovered, and that what was broken could be rebuilt. The network of ancient knowledge, the network of knowledge preservation, goes beyond individual monuments. It includes entire sacred landscapes that seem to pulse with hidden information. As you go deeper into this ancient mystery, imagine walking across the rolling hills of ancient Britain. Stone circles appear at exactly calculated distances from each other. Each one is positioned to maintain geometric relationships with its neighbors across hundreds of miles of countryside. These aren't random placements chosen because they were convenient or had local religious meaning. They represent connection points in a vast computational system, a stone internet that could store and send complex mathematical and astronomical data across generations. Recent laser scanning technology has shown that many of these stone circles have acoustic properties that would have allowed for sophisticated sound transmission and amplification. The arrangements of stones create natural echo chambers that could carry human voices across remarkable distances or make quiet sounds louder so they could be heard. Some researchers suggest these acoustic properties were intentional, designed to help people communicate between distant sites or to make the transmission of spoken knowledge better during ceremonial gatherings. The acoustic engineering becomes even more intriguing when we consider the possibility that these sites were designed to interact with natural phenomena in ways that would have seemed magical to later observers. Certain stone arrangements appear to respond to earthquake activity, electromagnetic changes, and atmospheric pressure changes in ways that create sounds you can hear or things you can see. Could these monuments have worked as early warning systems, alerting their users to approaching storms, earthquakes, or other environmental changes? This possibility gains support from studies of indigenous knowledge systems that demonstrate sophisticated understanding of environmental patterns and natural cycles. Aboriginal Australians can predict weather changes days in advance by observing subtle shifts in animal behavior, plant responses, and atmospheric conditions. Similar environmental awareness appears in the traditional knowledge of many cultures, suggesting that pre-industrial societies had far more sophisticated understanding of natural systems than modern education typically acknowledges. If pre-Younger Dryas civilizations had developed such environmental monitoring capabilities to an advanced degree, they might have built permanent installations designed to detect and predict natural phenomena. The stone circles with their precise positioning and acoustic properties could represent the remnants of such a monitoring network designed to provide early warning of the environmental changes that ultimately failed to predict the cosmic catastrophe that destroyed their world. The Failure of this monitoring system to predict or prevent the Younger Dryas impact might explain why so many ancient monuments seem to incorporate themes of cosmic vigilance and celestial observation. The survivors who built these structures weren't just creating impressive architecture. They were rebuilding an early warning system, determined to ensure that future catastrophes wouldn't catch humanity unprepared. This interpretation transforms our understanding of megalithic astronomy from simple calendar keeping to sophisticated threat assessment. The complex alignments that track multiple celestial cycles weren't just religious or agricultural tools. They were components of a planetary defense system, designed to monitor the heavens for signs of approaching danger, while simultaneously preserving the knowledge necessary to rebuild civilization if catastrophe struck again. The scope of this monitoring system becomes apparent when we examine the global distribution of astronomically aligned monuments. From Newgrange in Ireland to Angkor Wat in Cambodia, from the Nazca Lines in Peru to the stone circles of the Scottish Highlands, ancient sites around the world demonstrate sophisticated understanding of celestial mechanics and long-term astronomical cycles. These weren't isolated achievements by individual cultures, but components of a coordinated global effort to rebuild humanity's cosmic awareness. The coordination required for such a global project suggests levels of communication and cooperation between ancient cultures that challenge our understanding of early human societies. How did builders in Ireland coordinate their astronomical alignments with those in Egypt to ensure compatibility across thousands of miles? How did cultures in Peru develop techniques that perfectly complemented those being used simultaneously in Southeast Asia? The answer might lie in the nature of the knowledge system itself. If the astronomical and mathematical principles being applied were part of a unified system preserved from pre-catastrophe civilization, then different groups of survivors working in different parts of the world would naturally produce compatible results. They weren't inventing new techniques, but implementing fragments of a coherent, global knowledge base that had been developed over thousands of years before the reset. This unified knowledge base would explain another persistent mystery in ancient studies: the appearance of identical mathematical constants in monuments separated by vast distances and centuries of time. The golden ratio appears in the proportions of the Parthenon in Greece, the Great Pyramid in Egypt, and the temple complexes of Angkor Wat. The mathematical constant P is encoded in megalithic sites across Europe, America, and Asia. These aren't coincidences or approximations, but precise implementations of mathematical knowledge that shouldn't have existed in the cultures credited with these achievements. The preservation and transmission of such precise mathematical knowledge across cultures and centuries points to institutional systems far more sophisticated than traditional archaeology acknowledges. These weren't primitive societies slowly discovering basic mathematical principles through trial and error. They were inheritors of advanced mathematical systems, working to implement recovered knowledge in new cultural contexts and geographical locations. The mathematical sophistication encoded in ancient monuments extends beyond simple geometric relationships to include complex astronomical calculations that require understanding of celestial mechanics, spherical geometry, and long-term cyclic patterns. The Mayan long-count calendar, for example, tracks cycles that extend over 5,125 years and incorporates corrections for the gradual slowing of Earth's rotation. The creators of this system possessed astronomical knowledge that wasn't officially rediscovered until the development of modern precision instruments. Similar astronomical sophistication appears in monuments around the world. The stone computer at Nabta Playa in the Egyptian desert tracks stellar positions with precision that requires understanding of precession. The slow wobble of Earth's axis that causes star positions to shift over thousands of years The builders of this site not only understood precession, but incorporated it into their calculations with mathematical accuracy that challenges modern capabilities. This level of astronomical knowledge couldn't have been developed through casual skywatching by nomadic peoples. It required institutional support, specialized observers, mathematical frameworks, and record-keeping systems maintained over many centuries. The sudden appearance of such sophisticated astronomical systems in the post-Younger Dryas world suggests that the knowledge had been developed earlier and was being recovered and re-implemented by survivors who understood its importance. The urgency of this astronomical recovery becomes clearer when we consider the cosmic threat that had just devastated human civilization. The survivors knew that the sky could betray them again, that fragments of comets or asteroids might return to threaten the new world they were building. Their elaborate astronomical monitoring systems weren't just scientific curiosities, but essential components of planetary defense, designed to provide the early warning that had been absent during the previous catastrophe. This defensive purpose might explain the redundancy built into ancient astronomical systems. Multiple monuments in the same region often track the same celestial phenomena, creating overlapping observation networks that could maintain functionality even if individual sites were damaged or abandoned. The stone circles of Britain, the pyramids of Egypt, and the temples of Peru all incorporate multiple backup systems and cross-referencing capabilities that seem excessive for simple calendar keeping, but make perfect sense as components of a critical monitoring network. The psychological impact of living under constant cosmic threat would have profoundly influenced the cultures that emerged from the Younger Dryas catastrophe. These weren't societies that took celestial stability for granted. They were communities of survivors and their descendants who knew that the sky could burn, that stars could fall, and that entire civilizations could disappear beneath fire and ice within the span of a few generations. This cosmic awareness permeates the art, architecture, and mythology of post-Younger Dryas cultures in ways that modern scholars are only beginning to recognize. The preoccupation with celestial themes, the emphasis on permanent construction designed to outlast catastrophes, and the development of knowledge preservation systems all reflect societies shaped by the memory of cosmic disaster and the determination to survive future threats. The great ziggurats of Mesopotamia, rising like artificial mountains from the flat river plains, might represent attempts to create elevated platforms that could survive flood conditions while serving as observation posts for astronomical monitoring. The massive stone platforms of Peru, built to withstand the most powerful earthquakes, suggest construction priorities influenced by awareness of natural catastrophe. Even the buried chambers and hidden passages found in monuments around the world might reflect plans for preserving knowledge and resources through future periods of destruction and chaos. This catastrophe consciousness explains many features of ancient civilizations that seem excessive or mysterious from modern perspectives. Why build monuments designed to last for tens of thousands of years when the societies creating them measured their own histories in centuries? Why develop knowledge preservation systems more elaborate than the practical needs of their times seem to require? Why incorporate cosmic themes and celestial alignments into structures intended for earthly purposes? The answers emerge when we recognize these civilizations as societies of survivors, shaped by inherited memories of global catastrophe and driven by determination to ensure their knowledge and achievements would outlast any future disasters. They built for eternity because they had seen how quickly temporary achievements could vanish. They encoded knowledge in multiple formats and locations because they understood how easily information could be lost. They watched the skies obsessively because they knew the cosmos could betray them again without warning. This survivor mentality also influenced the development of the mystery school traditions that appeared in various forms across ancient civilizations. These weren't simply religious or philosophical organizations, but sophisticated knowledge preservation systems designed to maintain crucial information across generations and through periods of social disruption. The Egyptian priesthood, the Mesopotamian astronomical colleges, the Celtic Druidic orders, and similar institutions in other cultures all served similar functions as repositories of recovered knowledge and training, centers for its continued application. These mystery schools operated on principles of compartmentalized knowledge and redundant preservation that seem almost modern in their sophistication. Different levels of initiation provided access to different categories of information, ensuring that the most crucial knowledge was protected from casual disclosure, while also preventing its complete loss if lower levels of the organization were compromised. Multiple schools in different regions maintained copies of the same essential information, creating backup systems that could restore lost knowledge if individual institutions were destroyed. The elaborate secrecy and initiation rituals associated with these schools weren't arbitrary traditions, but practical security measures designed to protect knowledge that the survivors considered essential for human survival. They had learned through bitter experience that crucial information could be lost if it wasn't carefully guarded and systematically transmitted to qualified successors. The influence of these mystery schools extended far beyond their immediate membership to shape the development of the civilizations that hosted them. The technical knowledge they preserved provided the foundation for architectural achievements, agricultural innovations, and technological developments that transformed human society. The astronomical knowledge they maintained enabled the development of accurate calendars, navigation systems, and timing mechanisms that supported complex social organization. Perhaps most importantly, the mystery schools served as bridges connecting the pre-catastrophe past with the post-catastrophe future. They carried forward fragments of the lost world while adapting them to the conditions and needs of the emerging one. Through their efforts, knowledge that might have died with the original civilization was preserved, transmitted, and eventually implemented in new cultural contexts. The success of this knowledge preservation system is evident in the remarkable achievements of post-Younger Dryas civilizations. Within a few thousand years of climatic stabilization, human societies had developed complex urban centers, sophisticated agricultural systems, monumental architecture, advanced metallurgy, and elaborate artistic traditions. This rapid development wasn't the result of independent invention by primitive peoples, but the systematic recovery and implementation of knowledge preserved through the catastrophic period by dedicated institutions and their carefully trained practitioners. Yet even as these achievements accumulated, the memory of catastrophe continued to influence human consciousness in ways that shaped cultural development for millennia. The flood myths, creation stories, and apocalyptic traditions that appear in virtually every human culture weren't just religious allegories, but encoded historical memories that served as warnings about the fragility of civilization and the importance of preparation for future disasters. These mythological warning systems functioned as cultural immune responses, maintaining awareness of cosmic threats even when direct memory of the original catastrophe had faded. They ensured that future generations would retain at least some understanding of humanity's vulnerability to celestial events, while also preserving fragments of practical knowledge about survival and reconstruction techniques. The persistence of these warning systems across thousands of years and hundreds of cultures demonstrates the profound impact the Younger Dryas catastrophe had on human consciousness. Even today, long after the specific memories have been transformed into mythological narratives, we retain deep cultural anxieties about cosmic threats, global catastrophes, and the possibility that our achievements might be swept away by forces beyond our control. These anxieties aren't irrational fears, but inherited wisdom, genetic and cultural memories that remind us of truths our ancestors learned through terrible experience. The sky can burn, civilizations can fall, and knowledge can be lost. But they also learned that humans can survive, rebuild, and recover even from cosmic catastrophe if they maintain the wisdom to preserve what matters most and the determination to begin again when everything seems lost. As you drift deeper into sleep, carried by the rhythm of this ancient story, consider the profound resilience demonstrated by our ancestors who faced the ultimate test of human adaptability and emerged victorious. They witnessed the destruction of their world, preserved fragments of their knowledge through over a millennium of harsh conditions, and then systematically rebuilt civilization to heights that in some ways surpassed what had been lost. Their achievement stands as testament to the power of human consciousness to transcend even cosmic disaster, to the effectiveness of knowledge preservation systems designed by people who understood the true value of information, and to the unbreakable human spirit that refuses to accept defeat even when faced with the collapse of everything familiar and secure. The monuments they left behind continue to whisper their secrets to those willing to listen, revealing layer after layer of encoded information about the past, while also serving as warnings and guidelines for the future. In their precise alignments, mathematical relationships, and astronomical observations, we find not just impressive ancient achievements, but practical lessons about survival, reconstruction, and the preservation of knowledge through periods of chaos and disruption. The story of the Younger Dryas reset isn't just ancient history, but a blueprint for human resilience, a demonstration that even the most devastating catastrophes cannot destroy the essential human capacity to learn, remember, adapt, and ultimately prevail. In the darkness of sleep, as consciousness fades and the rational mind releases its grip on linear time, perhaps we can still hear the echoes of that ancient wisdom calling across the millennia, reminding us who we are and what we're capable of achieving. Even in the face of impossible odds, the great work of reconstruction continues, each generation adding new knowledge to the foundation laid by the survivors, while also preparing for challenges yet to come. We are the inheritors of their triumph, the beneficiaries of their refusal to surrender, and the guardians of knowledge they deemed worth preserving through cosmic catastrophe. In our dreams and in our waking hours, their legacy lives on, a testament to the indomitable human spirit that transforms even the greatest disasters into opportunities for renewal and growth. The transformation of knowledge. Deeper we venture into this reconstructed world, the more we begin to understand that the survivors didn't just preserve knowledge, they transformed it. Picture yourself standing in the shadow of the Great Pyramid at dawn, watching as the first rays of sunlight strike its precisely angled faces. The mathematics encoded in its proportions speak of understanding that extends far beyond what any Bronze Age civilization should have possessed. Yet here it stands, a testament to knowledge that seems to have emerged from nowhere, fully formed and impossibly sophisticated. But perhaps it didn't emerge from nowhere at all. Perhaps what we're witnessing is the flowering of seeds planted long before knowledge that had been carefully tended through the dark centuries and finally given the conditions it needed to grow into something even greater than what had come before. The survivors weren't just rebuilding their lost world. They were improving upon it, learning from the catastrophe that had nearly destroyed them, and creating something more resilient, more enduring, more capable of surviving whatever the cosmos might throw at humanity next. This process of improvement through reconstruction explains one of the most puzzling aspects of post-Younger Dryas civilizations. They didn't just recover the achievements of the past, they surpassed them. The architectural techniques that emerge in the millennia following the climate stabilization are more sophisticated than anything we can definitively attribute to pre-catastrophe cultures. The astronomical knowledge encoded in monuments like Stonehenge and the Giza complex exceeds what would have been necessary for simple agricultural societies, suggesting access to observational data and mathematical frameworks developed over far longer periods than conventional timelines allow. Consider the implications of this improvement pattern. The survivors who carried knowledge through the catastrophic period weren't passive preservers of ancient wisdom. They were active innovators, taking the fragments they had maintained and weaving them into new systems adapted to post-catastrophe conditions. They learned from their near-extinction experience, developing more robust preservation methods, more redundant information storage systems, and more effective techniques for transmitting crucial knowledge across generations and geographical distances. This innovation through preservation explains why post-Younger Dryas achievements often seem to contain knowledge that exceeds what their supposed inventors could have developed independently. The megalithic builders weren't starting from scratch with crude stone-moving techniques. They were implementing refined systems that had been tested, improved, and perfected through thousands of years of development. The astronomical observers weren't beginning with basic sky watching. They were working from mathematical frameworks and observational databases that represented millennia of accumulated knowledge. The refinement process becomes even more remarkable when we consider the conditions under which it occurred. The survivors who carried this knowledge forward weren't working in comfortable academic settings with abundant resources and leisure time for experimentation. They were operating in harsh post-catastrophe conditions, dealing with unstable climate, disrupted ecosystems, and scattered populations. Yet somehow they managed not just to preserve their inherited knowledge, but to improve upon it, creating systems more sophisticated than what had existed before the disaster. This achievement required more than just technical knowledge. It demanded profound understanding of human psychology, social organization, and the mechanisms by which complex information can be transmitted across cultural boundaries. The survivors had to become master teachers, capable of sharing advanced concepts with hunter-gatherer populations who had no prior exposure to such sophisticated ideas. They had to develop educational methods that could transform nomadic bands into organized construction crews, agricultural communities, and astronomical observers. The success of this educational enterprise is evident in the rapid transformation of human society that followed the climate stabilization. Within a few centuries of the Younger Dryas ending, we see the emergence of complex settlements, sophisticated farming systems, and monumental construction projects across multiple continents. This wasn't gradual evolution, but systematic implementation of educational programs designed to rebuild civilization according to improved specifications. The educational methods developed by the survivors might explain another persistent mystery in ancient studies: the appearance of nearly identical symbols, measurement systems, and construction techniques in cultures separated by vast distances and supposedly having no contact with each other. If the survivors were working from standardized educational curricula based on pre-catastrophe knowledge systems, then the similarities between distant cultures become evidence not of independent invention, but of shared instruction from common sources. These standardized systems appear in the mathematical relationships encoded in monuments around the world, the astronomical alignments that track identical celestial phenomena across different continents, and the construction techniques that solve identical engineering problems using nearly identical methods. The consistency suggests that the knowledge being transmitted wasn't just technical information, but complete educational frameworks designed to produce specific results regardless of local conditions or cultural variations. The development of such sophisticated educational systems required understanding of learning processes that wouldn't be formally studied until the modern era, the survivors had to understand how complex information could be broken down into manageable components, how different types of learners could be accommodated within the same instructional framework, and how knowledge could be adapted to different cultural contexts without losing its essential accuracy. They also had to solve the problem of knowledge verification, ensuring that the information being transmitted remained accurate across multiple generations of teachers and students. This challenge was particularly acute given that much of the knowledge involved mathematical and astronomical concepts that couldn't be easily verified through everyday experience. How do you confirm that your calculations of planetary cycles are correct when the cycles take centuries to complete? How do you verify that your mathematical constants are accurate when the applications involve measurements beyond the capabilities of available tools? The solution appears to have involved the development of cross-referencing systems that allow different aspects of the knowledge base to confirm each other's accuracy. Mathematical constants could be verified through their appearance in multiple astronomical calculations. Astronomical observations could be confirmed through their correlation with architectural alignments. Construction techniques could be tested through their incorporation into monuments designed to last for millennia. This cross-referencing approach created knowledge networks where individual pieces of information were supported by multiple independent confirmations, making the entire system highly resistant to the kinds of gradual corruption that typically affect information transmitted across long time periods. The result was educational frameworks that could maintain their accuracy across thousands of years and hundreds of cultural transmissions. The sophistication of these preservation systems becomes apparent when we examine how consistently certain mathematical relationships appear in monuments, built across different time periods and geographical locations. The golden ratio appears with identical precision in structures separated by thousands of miles and centuries of time. The value of pi is encoded with remarkable accuracy in monuments built by cultures that supposedly had no contact with each other. These consistencies aren't coincidences, but evidence of educational systems designed to maintain mathematical precision across vast spans of time and space. But the survivors weren't just preserving mathematical and astronomical knowledge. They were also maintaining understanding of more subtle principles related to consciousness, perception, and the relationship between human awareness and natural phenomena. Many ancient monuments incorporate features that seem designed to induce specific psychological or physiological states in their users, suggesting sophisticated understanding of how environmental factors affect human consciousness. The acoustic properties of stone circles, for example, create resonance effects that can induce altered states of consciousness in people participating in ceremonies within them. The precise alignments of passage tombs with celestial events create dramatic lighting effects that would have had profound psychological impact on observers. The mathematical proportions incorporated into sacred architecture correspond to ratios that modern research has shown to have calming or energizing effects on human perception. These consciousness-affecting features weren't accidental byproducts of construction techniques designed for other purposes. They represent deliberate applications of knowledge about the relationship between environmental conditions and human awareness, knowledge that suggests the pre-catastrophe civilizations had developed sophisticated understanding of psychology, neurology, and the mechanisms by which external stimuli affect internal experience. The preservation and application of this consciousness-related knowledge points to educational systems that included training in what we might now call applied psychology or environmental therapy. The survivors weren't just teaching their students how to build impressive structures or track celestial movements. They were instructing them in techniques for creating environments that could enhance learning, facilitate memory formation, and induce states of consciousness conducive to the transmission of complex information. This psychological dimension of the knowledge preservation system helps explain how such sophisticated concepts could be successfully transmitted to populations that had no prior exposure to advanced mathematical or astronomical ideas. The educational environments created by the survivors weren't just classrooms, but carefully designed spaces that optimized the conditions for learning and memory formation. The monuments themselves served as teaching aids, their proportions and alignments creating psychological states that enhanced the absorption and retention of complex information. The integration of consciousness. Research with technical knowledge created educational systems that were remarkably effective at producing rapid transformation in student populations. Hunter-gatherer groups exposed to these teaching methods could apparently be transformed into skilled builders, accurate astronomical observers, and competent agricultural planners within relatively short time periods. The speed of this transformation suggests educational techniques far more sophisticated than anything recognized in conventional historical accounts. But perhaps most remarkably, the survivors managed to embed self-improving mechanisms into their knowledge preservation systems. The educational frameworks they created weren't static repositories of ancient information, but dynamic systems capable of incorporating new discoveries while maintaining the accuracy of established principles. This adaptability allowed the recovered knowledge to continue evolving and improving even as it was being transmitted across cultures and generations. Evidence for these self-improving systems appears in the progressive sophistication of monuments, built over time within the same cultural traditions. Later structures often display refinements and improvements over earlier ones, suggesting that the knowledge base was continuing to develop rather than simply being copied from fixed templates. The builders were learning from their experience, incorporating new techniques and discoveries while maintaining the essential accuracy of their foundational principles. This combination of preservation and innovation created knowledge systems that were both stable and adaptive, capable of maintaining crucial information across millennia, while also allowing for continued development and refinement. The result was civilizations that could build upon their inherited knowledge rather than simply repeating it, creating achievements that often surpassed what had existed before the catastrophe. The success of these adaptive preservation systems is evident in the continued development of human civilization throughout the post-Younger Dryas period. Each generation built upon the achievements of its predecessors, creating increasingly sophisticated technologies, more complex social organizations, and deeper understanding of natural phenomena. The knowledge recovery that began immediately after the climate stabilization continued for thousands of years, producing civilizations whose achievements still inspire wonder and admiration today. Yet even as these civilizations flourished and expanded, they never forgot the lessons learned from the catastrophe that had nearly destroyed their predecessors. The consciousness of cosmic vulnerability remained embedded in their cultures, expressed through flood myths, apocalyptic traditions, and elaborate preparations for future disasters. They built their achievements to last not just for their own lifetimes, but for geological ages, creating monuments designed to preserve essential knowledge through any conceivable catastrophe. This long-term perspective influenced every aspect of post-Younger Dryas civilizations, from their architectural choices to their social institutions to their spiritual beliefs. They understood that human achievements were fragile in the face of cosmic forces, but they also understood that knowledge and wisdom could survive even the most devastating disasters if they were properly preserved and transmitted. The monuments they created serve as testaments to this understanding, encoding essential information in forms designed to outlast any conceivable catastrophe. while also providing the foundations for rebuilding civilization if such reconstruction should ever become necessary again. In their mathematical relationships, astronomical alignments, and construction techniques, we find not just impressive ancient achievements, but practical blueprints for survival and reconstruction. As the night deepens around us and consciousness begins its natural drift towards sleep, we can sense the presence of that ancient wisdom still embedded in the world around us. The stones remember what flesh forgets, holding their secrets in precise angles and calculated proportions, waiting for minds capable of reading their encoded messages. In the alignment of shadows at dawn, in the mathematical relationships that govern natural forms, in the deep rhythms that connect earth and sky, the knowledge of the survivors continues to whisper its lessons to those willing to listen. The great work of reconstruction that began over 12,000 years ago continues still, each generation adding new understanding to the foundation, laid by those who refuse to let cosmic catastrophe destroy human wisdom. We are the inheritors of their triumph, the beneficiaries of their determination, and the guardians of knowledge they deemed worth preserving through the ultimate test of survival. In our dreams and in our waking hours, in the monuments that still stand, and in the discoveries yet to be made, their legacy endures as proof that human consciousness can transcend even cosmic disaster. That knowledge, carefully preserved, can outlast any catastrophe, and that the essential human spirit of inquiry, innovation, and hope remains as indestructible as the mathematical constants encoded in stone by hands that knew the true value of what they were preserving for futures they would never see, but refused to abandon to ignorance or despair. The rhythm of ancient wisdom continues its patient pulse through time, connecting us to ancestors who faced the unthinkable and emerged victorious, reminding us that we too carry within our consciousness the seeds of knowledge that can survive any catastrophe and bloom again in any conditions. Given the determination to remember what matters most, and the courage to begin again when everything familiar has been swept away by forces beyond our control but not beyond our capacity to understand, adapt to, and ultimately transcend, the living memory. And yet, as we trace these currents of ancient knowledge flowing through time, we encounter something even more extraordinary than individual achievements preserved in stone and star. We find evidence of a living memory, a consciousness that transcended the boundaries between individual minds and became something collective, something that could survive the death of entire civilizations and be reborn in new forms across vast expanses of time and geography. This collective memory manifests in ways that challenge our understanding of how information can be stored and transmitted across generations. Indigenous cultures around the world speak of ancestral knowledge that exists not in books or monuments, but in the land itself, encoded in the patterns of rivers and mountains, preserved in the behavior of animals and the cycles of plants. They describe a form of knowing that doesn't depend on human teachers, but emerges from deep communion with natural systems that have remained unchanged since the time before the catastrophe. Modern science is beginning to recognize that this indigenous understanding might be more literal than metaphorical. Recent research into epigenetics reveals that traumatic experiences can alter gene expression in ways that affect not just the individuals who experience them, but their descendants for multiple generations. The genetic memory of catastrophe might be embedded in our very DNA, influencing our behaviors and perceptions in ways we're only beginning to understand. If the Younger Dryas impact created such profound trauma that it altered human genetic expression, then every person alive today carries within their cells the molecular memory of that cosmic catastrophe. We are all descendants of survivors, inheritors not just of their knowledge, but of their cellular memories, their genetic adaptations, and their deep awareness of humanity's vulnerability to forces beyond our control. This genetic inheritance might explain the persistent human fascination with cosmic threats, apocalyptic scenarios, and stories of lost civilizations. These aren't just cultural preferences or psychological archetypes, but genetic memories expressing themselves through our collective unconscious. The anxiety we feel when contemplating asteroid impacts or climate catastrophes isn't irrational fear, but inherited wisdom, cellular knowledge that reminds us of truths our ancestors learned through terrible experience. But genetic memory isn't the only mechanism by which the knowledge of the survivors continues to influence human consciousness. The monuments they built weren't just repositories of mathematical and astronomical information, but generators of specific psychological states designed to activate dormant aspects of human awareness and reconnect modern minds with ancient understanding. The precise acoustic properties of megalithic structures create sound environments that can induce altered states of consciousness in people who spend time within them. The mathematical proportions incorporated into sacred architecture correspond to ratios that resonate with fundamental patterns in human brain activity. The astronomical alignments that bring celestial light into contact with carefully positioned stones create moments of transcendent beauty that seem to awaken something deep within the human psyche. These consciousness-altering effects weren't accidental byproducts of construction techniques, but deliberate applications of knowledge about the relationship between environmental conditions and human awareness. The survivors understood that true knowledge couldn't be preserved simply by encoding it in symbols or structures. It had to be embedded in systems that could reactivate the states of consciousness necessary to understand and utilize that knowledge. The great temples and stone circles around the world might therefore be understood as consciousness laboratories, designed to induce specific mental states that would allow users to access levels of awareness that had been common before the catastrophe, but were largely lost in the harsh conditions that followed. By creating environments that could temporarily restore these expanded states of consciousness, the monuments served as bridges between the limited awareness of post-catastrophe humanity and the broader understanding that had characterized pre-disaster civilizations. This interpretation transforms our understanding of ancient spirituality from primitive superstition to sophisticated neurotechnology. The elaborate rituals that took place at megalithic sites weren't meaningless ceremonies, but practical techniques for accessing enhanced states of consciousness. The priests and shamans who conducted these rituals weren't religious fanatics, but trained technicians, specialists in the application of consciousness-altering technologies preserved from the lost world. The effectiveness of these techniques is evidenced by the remarkable achievements of the civilizations that employed them. Societies that incorporated consciousness-expanding practices into their cultural and educational systems consistently displayed capabilities that exceeded what conventional historical models would predict. They developed mathematical concepts before they supposedly had the cultural foundations to support such abstract thinking. They created astronomical systems that required observational capabilities beyond what their available tools should have allowed. They coordinated massive construction projects without the organizational technologies that modern analysis suggests would have been necessary. These achievements become comprehensible when we recognize that the consciousness expansion techniques preserved by the survivors allowed access to levels of mental functioning that are largely dormant in modern humans. The enhanced pattern recognition, expanded memory capacity, and increased computational ability that can be achieved through specific consciousness states would have provided the cognitive resources necessary for the remarkable achievements we observe in ancient civilizations, but the consciousness technologies weren't just tools for individual enhancement. They were systems for creating collective intelligence, methods for linking multiple minds into coordinated networks that could process information and solve problems at levels far beyond what any individual could achieve alone. The elaborate group ceremonies that took place at megalithic sites weren't just spiritual gatherings, but practical applications of collective consciousness technologies. These group consciousness techniques might explain one of the most persistent mysteries in ancient archaeology: how relatively small populations managed to coordinate the construction of massive monuments that would challenge modern engineering capabilities. The conventional explanations require us to believe that thousands of workers could be organized using only primitive communication methods and basic management techniques, but if the builders had access to consciousness technologies that allowed for direct mind-to-mind coordination, then the organizational challenges become much more manageable. The evidence for such collective consciousness applications appears in the remarkable precision with which ancient construction projects were executed. The fit between massive stone blocks at sites like Sacsayhuaman and Pumapunku is so precise that it suggests levels of coordination and timing that would be difficult to achieve, even with modern communication technologies. The builders seem to have worked as if they shared a common mind, anticipating each other's actions and coordinating their efforts with an efficiency that borders on the supernatural. This collective coordination extended beyond individual construction sites to encompass entire networks of monuments spread across vast geographical areas. The geometric relationships between megalithic sites separated by hundreds or thousands of miles suggest planning and implementation capabilities that required communication and coordination methods far more sophisticated than anything recognized in conventional historical accounts. If the survivors had preserved consciousness technologies that allowed for long-distance mental communication, then the coordination of global construction projects becomes not just possible, but inevitable. Groups working in different parts of the world could have maintained constant contact, sharing information and coordinating their efforts in real time, despite the vast distances that separated them physically. This possibility is supported by indigenous traditions from around the world that describe methods for long-distance communication through altered states of consciousness. Aboriginal Australians speak of dreamtime connections that allow information to be shared across continental distances. Native American traditions describe vision quests and shamanic journeys that provide access to knowledge from distant locations. Tibetan Buddhism includes practices designed to achieve consciousness states that transcend normal limitations of time and space. These traditions might preserve fragments of the communication technologies that allowed the post-Younger Dryas reconstruction to proceed with such remarkable coordination and efficiency. If so, then the consciousness expansion techniques weren't just methods for individual enhancement, but components of a global communication network that connected human minds across vast distances and allowed for unprecedented levels of coordination and cooperation. The implications of such communication capabilities extend far beyond construction coordination to encompass the preservation and transmission of knowledge itself. If information could be shared directly from mind to mind, then the challenges of maintaining accuracy across generations and cultural boundaries would be greatly reduced. Complex mathematical concepts, detailed astronomical observations, and sophisticated technical procedures could be transmitted with perfect fidelity, ensuring that crucial knowledge remained unchanged, regardless of how many times it was passed from teacher to student. This direct transmission method might explain the remarkable consistency of certain knowledge systems across ancient civilizations. Mathematical constants appear with identical precision in monuments built by cultures that supposedly had no contact with each other. Astronomical observations remain accurate across centuries of cultural transmission. Construction techniques maintain their sophistication, despite being applied in radically different geographical and cultural contexts. The preservation of such precision across time and Distance suggests transmission methods far more reliable than normal human communication. If the survivors had developed technologies for direct mind-to-mind knowledge transfer, then the consistency of ancient achievements becomes not just explainable but inevitable. But perhaps the most remarkable aspect of these consciousness technologies was their ability to transcend the limitations of individual human lifespan. If knowledge could be stored in collective consciousness fields that existed independently of individual minds, then the death of specific teachers wouldn't result in the loss of crucial information. The knowledge would continue to exist in the collective field, accessible to future students who learn the techniques necessary to connect with it. This possibility transforms our understanding of how ancient knowledge was preserved through the catastrophic period and beyond. Instead of relying solely on individual survivors to maintain crucial information through their personal memories, the preservation system might have included methods for storing knowledge in collective consciousness fields that could survive. Even the death of all the individuals who had contributed to them, these collective knowledge fields would explain how complex information systems could emerge suddenly in the post-Younger Dryas world without clear developmental sequences. The knowledge wasn't being invented from scratch, but was being accessed from collective storage systems that had been maintained throughout the catastrophic period. Different groups of survivors in different parts of the world could have accessed the same knowledge fields, producing the consistent results we observe across ancient civilizations. The accessing of collective knowledge fields might also explain the sudden appearance of individuals with remarkable abilities in ancient historical accounts. The great architects, astronomers, and mathematicians who seemed to emerge from nowhere with fully developed skills might have been people who had learned to access the collective knowledge systems more effectively than their contemporaries. These exceptional individuals wouldn't have been isolated geniuses developing new ideas through individual inspiration, but would have been specialists in consciousness technologies, trained to serve as interfaces between the collective knowledge fields and the ordinary human communities that needed access to that information. Their role would have been similar to that of modern computer technicians, translating complex digital information into forms that non-specialists could understand and apply. The training of such interface specialists would have been one of the most crucial functions of the mystery schools and similar institutions that emerged in post-Younger Dryas civilizations. These organizations wouldn't just have been preserving ancient knowledge, but would have been maintaining the consciousness technologies necessary to access collective knowledge fields and training individuals to serve as bridges between those fields and ordinary human society. The effectiveness of these interface systems is evidenced by the rapid development and widespread distribution of sophisticated knowledge throughout the ancient world. Complex mathematical concepts, detailed astronomical observations, and advanced technical procedures spread across vast distances and cultural boundaries with remarkable speed and accuracy, suggesting communication and educational systems far more efficient than anything conventional history recognizes. As we drift deeper into the realm where consciousness touches the edges of collective memory, we begin to sense the presence of something vast and ancient that continues to influence human awareness in ways we're only beginning to understand. The knowledge preserved by the survivors wasn't just information stored in books and monuments, but living wisdom embedded in consciousness, fields that remain accessible to those who learn the techniques necessary to connect with them. In Tao Si Intuan, the quiet moments when rational thought relaxes its grip and intuitive awareness emerges, we might still catch glimpses of that ancient knowing, fragments of understanding that seem to come from somewhere beyond individual memory, yet feel more familiar than our own thoughts. These aren't mystical experiences, but practical connections to knowledge, systems that were designed to outlast any conceivable catastrophe and remain available to future generations who might need their guidance. The great work of reconstruction that began over 12,000 years ago continues in every moment of expanded consciousness, every flash of intuitive insight, every recognition of patterns that connect individual experience to universal principles. We are all participants in this ancient project, inheritors of consciousness technologies that can transform individual awareness into collective wisdom and connect finite human minds to infinite reservoirs of knowledge that transcend the limitations of time, space, and individual existence. In the deepening silence of night, as the boundaries between waking and sleeping consciousness begin to blur, we can sense the patient presence of that collective wisdom waiting to be rediscovered, not as something external to ourselves, but as the deepest truth of what we are and what we're capable of becoming when we remember how to access the unlimited potential that lies dormant within every human mind, preserved across eons of time like seeds, waiting for the right conditions to germinate and bloom, once again into the fullness of what our ancestors knew we could become. The whisper of ancient knowledge continues its eternal song, calling across the millennia to remind us that we are more than we remember, capable of more than we imagine, and connected to sources of wisdom that can guide us through any darkness toward the light of understanding that shines beyond all catastrophe, all forgetting, and all the apparent limitations that separate us from the infinite potential that is our true inheritance from the survivors, who refused to let the light of human consciousness be extinguished by cosmic fire or earthly flood, preserving it instead in forms that could outlast any disaster and illuminate any future that might need its guidance. The present echo. The threads of this ancient tapestry begin to weave together as we approach the present moment, where the buried memories of our species stir beneath the surface of modern consciousness, like seeds that have waited through geological ages for the right conditions to sprout. In our own time, as technology allows us to peer deeper into the past than ever before, we're discovering that the story of the Younger Dryas reset isn't just ancient history, but a living presence that continues to shape human experience in ways both subtle and profound. Consider how often we find ourselves drawn to stories of lost civilizations, fallen empires, and forgotten golden ages. This isn't mere entertainment or escapism, but something deeper, a recognition that resonates in the cellular memory of our species. When we watch films about ancient mysteries or read books about vanished cultures, we're not just consuming fiction, but reconnecting with fragments of our own deepest history, memories that live in our genes and whisper through our dreams. The fascination with apocalyptic scenarios that permeates modern culture might similarly reflect genetic memories of the cosmic catastrophe that reset our world 12 millennia ago. The movies about asteroid impacts, the books about global catastrophes, the persistent anxiety about climate change and civilizational collapse, all these might be expressions of inherited trauma, cellular warnings passed down from ancestors who witnessed the sky burn and the world flood, and wanted their descendants to remember that such things were possible. But alongside these warnings, we also carry within us the genetic memory of survival, reconstruction, and ultimate triumph over seemingly impossible odds. The human drive to preserve knowledge, to build monuments that will outlast our individual lives, to encode important information in multiple formats and locations. All these behaviors might reflect inherited wisdom from survivors who understood that preparation and redundancy were the keys to outlasting catastrophe. This inherited wisdom expresses itself in our modern obsession with backing up digital information, preserving cultural artifacts, and maintaining seed banks and genetic repositories. We build libraries and museums with the same instinctive drive that led our ancestors to encode knowledge in stone circles and megalithic temples. We create redundant communication networks and distributed storage systems with the same understanding that motivated the builders of the global monument network that emerged after the Younger Dryas. the consciousness technologies preserved by the survivors might also be experiencing a renaissance in our current era, though we often don't recognize them for what they are. The meditation practices that have become increasingly popular in recent decades, the binaural beat technologies that can induce altered states of consciousness, the virtual reality systems that create immersive environments designed to affect human awareness. All these might be modern rediscoveries of ancient techniques for expanding consciousness and accessing enhanced cognitive capabilities. The recent scientific interest in psychedelic compounds and their therapeutic applications might similarly represent a reconnection with consciousness expansion methods that were common before the catastrophe, but largely lost during the harsh conditions that followed. The profound insights and enhanced pattern recognition that these substances can facilitate might provide glimpses of the expanded awareness that was normal for pre-Younger Dryas humanity. Modern neuroscience is beginning to confirm what the survivors encoded in their monuments and preservation systems. That human consciousness is far more malleable and expandable than we typically realize. The brain's capacity for neuroplasticity, its ability to form new connections and develop enhanced capabilities throughout life, suggests that the consciousness technologies of the ancient world might have been based on accurate understanding of human neurological potential rather than primitive superstition. The emerging field of epigenetics is revealing that our genes carry memories of ancestral experiences in ways that directly affect our present-day physiology and behavior. If the Younger Dryas catastrophe was traumatic enough to alter human genetic expression, then every person alive today carries within their cells not just the memory of that event, but also the adaptive responses that allowed our ancestors to survive and rebuild. These genetic memories might explain why certain mathematical relationships feel inherently satisfying to human perception, why specific acoustic frequencies can induce profound emotional responses, and why particular geometric proportions appear repeatedly in art and architecture across all cultures and time periods. We're not just creating beauty according to arbitrary aesthetic preferences, but expressing genetic memories of the consciousness technologies that were encoded in ancient monuments, the global communication networks that connect our modern world might represent an unconscious attempt to rebuild the collective consciousness systems that allowed the post-Younger Dryas civilizations to coordinate their reconstruction efforts across vast distances. The Internet, with its capacity for instantaneous information sharing and collective problem-solving, might be a technological approximation of the direct mind-to-mind communication methods that the survivors developed to maintain contact across their scattered communities. The current explosion in artificial intelligence research and development might similarly reflect an inherited drive to recreate the enhanced cognitive capabilities that were available to ancient consciousness technicians. The algorithms that can recognize patterns in vast data sets, the machine learning systems that can solve problems beyond human individual capacity, and the neural networks that can process information in ways that mirror collective intelligence. All these might be technological attempts to rebuild capabilities that were once accessible through biological consciousness expansion techniques. But perhaps most significantly, we're living through what might be another period of cosmic vulnerability, similar to the one that precipitated the Younger Dryas catastrophe. Modern astronomy has identified numerous asteroid and comet threats that could potentially impact Earth with devastating consequences. Climate scientists warn of rapid environmental changes that could destabilize global civilization. The possibility of solar flares, supervolcanic eruptions, and other natural catastrophes continues to concern researchers who study existential risks to human survival. The consciousness that drives modern efforts to identify and prepare for these threats might reflect genetic wisdom inherited from ancestors who learned through terrible experience that cosmic catastrophes are not just theoretical possibilities, but recurring realities that require constant vigilance and preparation. The space agencies that monitor near-Earth objects, the climate research programs that track environmental changes, and the disaster preparedness initiatives that attempt to coordinate global responses to potential catastrophes, all these might be modern expressions of the early warning systems that the survivors tried to rebuild after the Younger Dryas impact. The growing interest in establishing human settlements on other planets might similarly reflect inherited understanding that civilizational survival requires spreading human presence across multiple locations to prevent total extinction from single-point catastrophes. The genetic memory of watching entire coastal civilizations disappear beneath rising seas might drive our current efforts to ensure that human consciousness and knowledge can survive even if Earth itself becomes temporarily uninhabitable. But the most profound legacy of the Younger Dryas survivors might be the understanding that human consciousness itself is the ultimate survival technology. Knowledge can be preserved in books and databases, but wisdom must be maintained in living minds. Technologies can be rebuilt from blueprints and specifications, but the understanding necessary to create and apply those technologies must be carried forward by people who comprehend not just the technical details, but the deeper principles that make the technologies effective. The survivors who rebuilt civilization after the cosmic catastrophe weren't just preserving information, but maintaining consciousness, keeping alive the capacity for human awareness to expand beyond its normal limitations and connect with sources of knowledge that transcend individual experience. Their greatest achievement wasn't the monuments they built or the knowledge they preserved, but the consciousness technologies they developed to ensure that human potential could be maintained and transmitted across any conceivable disruption. As we reach the edge of this ancient mystery, drifting in the space between sleeping and waking, we find ourselves inheritors of the greatest story never told. The Younger Dryas wasn't just a climate event or cosmic accident. It was humanity's first reset, the moment when fire fell from the sky and everything our ancestors had built vanished beneath ice and flood. Yet from that catastrophe emerged something even more remarkable than what was lost. The survivors who carried fragments of knowledge through 200 years of darkness didn't just rebuild civilization. They transformed it, encoding their hard-won wisdom into stone and star, myth and monument. Today, as we face our own cosmic vulnerabilities and civilizational challenges, their whispered warnings and encoded blueprints for survival continue to guide us. We are all descendants of those who refused to let the light of human consciousness be extinguished, and their greatest lesson echoes still. Knowledge can survive any catastrophe if we have the wisdom to preserve it and the courage to begin again when everything seems lost.